Let us understand the arrangement of third order pulley system. In this arrangement, total number of pulleys is equal to the number of ropes used in the system. If we observe the diagram, there are 3 pulleys. So number of ropes used is equal to 3. Now out of these 3 pulleys, one pulley is fixed pulley which is connected to the fixed support at the top. We will give numbers to the pulley. So this is the pulley number 1 which is fixed. This is the second pulley which is movable, and this is the third pulley which is also movable. Now we have to apply effort to the last number of pulley, that is the pulley number 3, with the help of rope. So we will use the rope number 1. So effort is applied, we have to pass the rope over the pulley number 3. So I will use here one rope for which effort Fe is applied, which is in the downward direction. Now we will pass the rope over the pulley number 3, and here is the rigid base. So I will write here, this is the rigid base which is connected to the load Fl, and we will connect this rope to the rigid base. Now if we observe, this is the rope number 1, that is one rope is used, that is one end, at one end effort Fe is applied and the second end is connected to the rigid base. Now what is the tendency of this load? So load always tend to move in the downward direction. So this is the direction of the movement of the load, and because of the downward motion of the load, tension is created in this rope which is connected to the rigid base and which is in upward direction, that is in the opposite direction. So the rope end connected to rigid base, here is the tension created in the upward direction, and at this end of the pulley opposite direction tension is created. Now what is the magnitude of this tension? So if we observe, this simple rope pass over the pulley number 3, and at one end effort Fe is applied. So same amount of effort Fe is created here, that is tension is equal to this amount Fe is created, which is equal in magnitude but opposite in direction along this rope. Now we will use the second rope. Now second rope we have to connect to this pulley number 3 and we have to pass over the pulley number 2. So I will connect this rope. We have to pass over the pulley number 2 and this is the rope number 2. So I will show here, this is the rope number 2. Now what is the amount of tension created here? So if we observe Fe in the downward direction related to this pulley, so at this upward side of the pulley same amount of tension is created but in the opposite direction. So we will show here the direction. This is the direction related to pulley number 3, and what is the amount? Fe plus Fe, that is equal to 2Fe. So I will write here 2Fe amount tension is created. Now this end is connected to pulley number 3. Now the end which is in contact with pulley number 2, here also tension created but in opposite direction. So this amount of tension is equal to 2Fe. Now the same tension is there which is along the rope which is passed over the pulley number 2. So I will show here. So this is the same amount, that is equal to 2Fe. That is along this rope which is passed over the pulley number 2, tension is equal to 2Fe is created. Now here we will show the rope which is connected to rigid base, direction is in the upward direction. So same direction, that is direction is equal but magnitude is equal but direction is opposite and amount is 2 Fe. So if we observe, so I will show here this direction as well as magnitude, which is equal to 2 Fe. Now again, this is the second rope. Now we will connect the third rope. So we will connect the third rope to the pulley number 2 and we have to pass over the fixed pulley. So this is the rope number 3. Now if we observe, there are 3 number of pulleys and 3 number of ropes. Now what is the amount of tension? So if we observe pulley number 2, then in the downward direction 2 Fe plus 2 Fe, that is 4 Fe amount tension is created. So the rope attached to the upper side, here the same amount of tension but direction is opposite, that is 4 Fe is created, that is 2 Fe plus 2 Fe, that is 4 Fe. So same rope passes over the pulley number 1, so same tension is there. So I will show here the tension when it is passes over the pulley number 1. So at this end we will show tension that is equal to 4 Fe, and related to this rigid base, tension is in the opposite direction and it is equal to 4 Fe, and here at this end it is 2 Fe. Now if we observe all the rope, so this is the rope number 1, tension created is Fe. For rope number 2, tension created is 2 Fe. For rope number 3, tension created is 4 Fe. So what is the total tension? 4 plus 2 plus 1, that is equal to 7 Fe. So total effort is equal to 7 Fe for all these ropes. So how we can write this? So this Fl will move in the downward direction and this effort, this load Fl will move in the downward direction. So Fl is equal to this effort along with these 3 ropes will move in the upward direction, that is 4 plus 2 plus 1 Fe, that is equal to 7 Fe. So we will get this equation. So we will simplify this. So Fl by Fe, that is nothing but mechanical advantage. So mechanical advantage is equal to 7, and for ideal machine we can write velocity ratio is equal to mechanical advantage. So Vr is equal to 7. Now in this case we will use or we will consider all the number of pulleys. So total number of pulleys is equal to 3 and which is equal to n. So how to convert this 7 into n? That is, we have to write the formula in terms of n. So 7, that is, we can write in other way 2 raised to n minus 1, where n is the total number of pulleys. Now in previous 2 cases we have considered n is equal to number of movable pulleys, but in this case we will take total number of pulleys. Now for this diagram, number of fixed pulleys is equal to 1, number of movable pulleys is equal to 2, number of ropes is equal to 3, and which is equal to total number of pulleys, that is equal to n.
Given question: in third order pulley system there are 3 pulleys. A load of 1000 Newton is lifted by an effort of 180 Newton. Find the efficiency of the machine and effort lost in friction.
Let us understand the given data. This is the third order pulley system. Total number of pulleys is equal to 3. So we will consider in third order pulley system, value of n is equal to total number of pulleys in the system. So it is the value of n. Now load is equal to 1000 Newton. So Fl is 1000 Newton and applied effort Fe is equal to 180 Newton. Now we have to calculate efficiency of the system. So efficiency is the ratio of mechanical advantage by Vr, that is the velocity ratio. So mechanical advantage is the ratio of Fl by Fe. Both the values are known. Now we have to calculate velocity ratio. So for third order pulley system, Vr is equal to 2 raised to n minus 1, where n is 3, so which is equal to 7. Now when we put this value in the formula of efficiency, then we will get efficiency 0.7937, but efficiency we have to write in percentage, so 79.37% is the answer. Now we will move to the next question. So next question, we have to find out effort lost in friction. Now this effort lost in friction, that means we have to take the difference in between the effort in actual machine and effort in ideal machine. Now effort in actual machine, that is Fe, is known, 180 Newton. But the effort in ideal machine is not known, and this effort in ideal machine is FEI. So we will find out this value of FEI. Now for ideal machine, we know that mechanical advantage is equal to velocity ratio. So we will write for ideal machine MA is equal to VR. Now value of VR is calculated, that is equal to 7. Now for ideal machine, we have to find out FEI. So MA is equal to FL by FEI. So FL is 1000 Newton. So when we put the value, then we will get the value of FEI is equal to 142.86. So when we take the difference in between this 180 minus 142.86, then we will get the answer. Effort lost in friction is 37.14 Newton.